Let's take a look at Newton's law of universal gravity in its purest form. We're going to place three masses a distance apart from one another. Because each object with mass has a gravitational attraction, we'll find out the forces between them, and we'll find out the net force acting on one of the particular objects. So, we're going to start out by drawing three objects, one at 2 kilograms, another at 3, and another at 4. Place the bottom two a meter apart, and the side two, we're going to make them 4 meters apart. And I'm going to solve for the gravitational attraction between the 2 and the 3 kilogram masses. I'm going to use our universal gravity constant of 6.67 times 10 to the negative 11th newtons meters squared per kilogram squared, multiplied by both of those masses, divided by their distance from each other squared, and I get a force of 2.5 times 10 to the negative 11th newtons. So now we'll look at the 3 and the 4 kilogram mass. Same equation, Fg equals gmm over r squared. We're going to apply the gravitational constant, multiply it by those masses, the 3 kilogram mass and the 4 kilogram mass. And all of this is to find out what's the net force on the 3 kilogram mass there in the corner. When we calculate this out, we get 8 times 10 to the negative 10th newtons. Now, it's important to note that in yellow is the force between the 2 kilogram and the 3 kilogram mass, and it's making the 3 kilogram want to go up. And then on the bottom, we've got the 3 and the 4, and because those two are attracted, the 3 kilogram mass wants to go to the right. Those do not go in the same direction. And because they're not in the same direction, we are dealing with vectors. And we need to line up our vectors tip to tail. Line them up tip to tail to find out that resultant force. And so we're going to have the force from our A calculation going up, our B calculation going to the side, and then we're going to do A squared plus B squared equals C squared, the Pythagorean theorem, with those two forces to calculate our resultant. And that is the C squared. You take the square root, and when we take the square root, we get our resultant force, which is 8 times 10 to the negative 10th newtons, which ironically is the same as the force from our calculation between the 3 and the 4, but that's a matter of decimal places. But this problem gives us a good example of forces between objects. And the objects in this case are just circles. They can be any objects with mass, any distances away. Because this has an angle, we do Pythagorean theorem. If these were in a straight line and there were no angles, then we would be adding or subtracting based on which direction the forces would go.